in this video we will discuss the problem brackets in matrix chain multiplication. Previously this problem has been asked in some of the product based companies. So the problem says that we'll be given an array P which will be of length n, and it will be used to denote the dimensions of a series of matrices such that the ith matrix is denoted by Pi into Pi plus 1. So the dimension of the ith matrix is Pi into Pi plus 1. Okay. Now there are total n minus 1 matrices given, and we have to find the most effective way to multiply these matrices together. I'll explain this. Basically, first of all, what we have to do is we have to consider the matrix chain multiplication problem, and then after we have solved the matrix chain multiplication, so we will apply the brackets in this problem accordingly. So the problem is not actually to perform the multiplications, but merely to decide in which order to perform the multiplications. So basically we have to decide that in which order we'll be multiplying the matrices, such that the minimum number of operations is needed. So there are many options to multiply a chain of matrices, because matrix chain multiplication is associative in nature. We'll see this in the notes part as well. So no matter how one parenthesis the product, the result will be the same. So let us see some of the cases here. So let us say that if we take a matrix, like first of all let us understand what they are saying. So they are saying that given the matrices, multiply in such a way, we have to multiply the given matrices in such a way such that the total number of operations, right? Basically the total number of operations that we do should decrease, right? Should be minimum possible. Now what do we mean by that? Is there any difference when we multiply matrices in terms of operations? Yes. Suppose there is a matrix A which is of dimension 1 cross 2. Suppose that matrix A is of dimension 1 cross 2. Suppose there is a matrix B which is of dimension, let's say, 2 cross 3. Suppose there is another matrix C which is, let's say, of the dimension 3 cross 4. So if I apply the associative property of matrices, so we can understand that A into BC, where BC is multiplied before, okay, where BC is first of all multiplied, then the result is multiplied with A, is equal to AB into C, okay, because the matrix multiplication is associative. So let us see that how many operations we will take in the case of A into BC, okay. So in the case of A into BC, how many operations we will take? So first of all, we will multiply these two matrices. So if we multiply B and C, so how many operations we actually take? So we take nothing but 2 into 3 into 4 operations. Okay, that is nothing but this. 3 is common, then 4. So 2 into 3 into 4 operations is what we take. Then we get the resultant matrix. So we will get the resultant matrix BC, which will be of the dimension 2 cross 4, and we also had the matrix A which was of dimension 1 cross 2. So when we multiply this thing, that is A into BC combined, multiplied, so we will get what? We will get another thing, that is 1 into 2 into 4. So the overall cost will be 1 into 2 into 4 plus 2 into 3 into 4. Okay. So this is quite high compared to the other cost. Let us see what we will get when we multiply in other fashion. So let's say we have the matrix like A was there, that was 1 cross 2. Then the matrix B was there, which was 2 cross 3, let's say. Then let's say the matrix C was there, which was of the dimension 3 cross 4. So if we have these three matrices, suppose we tried another way, and the other way was AB first multiplied, then we multiplied the result with C. So if we multiply these two matrices, so in that case the result, the cost for it would be 1 into 2 into 3, and then once we have multiplied this AB matrix, so this AB matrix will be of dimension 1 cross 3. Now what will happen? I'll multiply this with the matrix C, which is of dimension 3 cross 4. So this will take up a cost of what? 1 into 3 into 4. So if we try to see the overall cost, so this is 6 operations, plus 12 operations, so total 18 operations is what I am taking here. In this A, B into C, I am taking 18 operations. But if I look up here, so I was taking total of what, how many operations? This was 8 plus 12 into 2, that was 24, so total 32 operations I was taking. So you can see that I am getting some lesser operations there. So my task will be to minimize the number of operations that I am doing. And how we can do it? So basically we will try, like if suppose that we have been given a bigger matrix combination, let's say we have been given matrix A, B, C and D. So we can try to do what? We can first of all try and find, let's say we can try to do the partition. Let's say we do the partition one time here, then one time we do the partition from here, one time we do the partition from here. So we'll try to do the partition from various possible scenarios. So what will happen is, we'll have A, okay, first of all let's say we have A, then we have B, C, D combined, okay. So we are doing the partition at A. Then another thing that we could have done is, we could have done the partition at this position. In that case it could be A, B and then C, D, okay. Suppose if we do the partition like this, okay, so we will get some cost from the left side from this AB multiplication, some cost from CD as well, and then suppose they are having the dimensions as A cross B and B cross C. So in that case what would happen is, basically my overall cost will be nothing but the left cost that I am getting, the left cost that I got, okay, that is the cost for AB for getting this product as AB, plus the right cost plus A into B into C, okay. So that is how we will get the cost each and every time. So how can we do this particular initiative? So now let us discuss this one as well. So let's say we are having this part, so this will be nothing but A, B, C combined and then D. So how will we get this? So again we will first of all we'll have the left, we'll have some operations for the left that will get through the recursive call, some operations through the right path that will get from the recursive call. Here will basically the number of operations will be 0 for this. Now so like this will be added with what, the dimensions, like suppose it is A cross B and this is B cross C, so the cost will be A into B into C, right? So this is how we'll take the overall cost. Now let us understand how we'll get some overlapping problems here. How does this fall into dynamic programming or overlapping sub problems? So let us see this. So if we are talking about this, so this could be taken like this: A, then B could go alone, and then C and D, then B could go alone here, and then C and D could be there. Or what could have happened is, it could be A, then B, C, and then D, and similarly for other cases. But if we will try and observe, so this particular sub problem C and D, if we observe this problem C and D which is there, it is also here. So we can see that how the problems are repeating. So we will not calculate the repeating sub problems, and for this, if we are following a top down approach, then we will use memoization for not calculating the already stored answer again and again. So what we will do in the normal part is, we will try to do the partition at every step. So let us have a look at the normal matrix chain multiplication code. So basically what we have is, in that case we have a 2D vector named as dp, which is of the dimension n cross n for storing the I comma j situation. So initially we'll mark it as -1, indicating that the particular state dp of ij is not calculated. Then what we do is, we run a recursive call named as function f. This function f will be recursive, will start from 1 till n-1. So that is where we can do the partition. We'll pass the array, we'll pass the n, we'll pass the dp part, and then in this function, if I is equal to j, so if I is equal to j, so that means that I and j are pointing at the same values. So this basically indicates that there is no matrix multiplication possible. So in that case we simply return a 0. Otherwise we check if the dp and ij, this is the code for matrix chain multiplication. We'll also see the code which is very similar for the brackets in matrix chain multiplication, because if we know matrix chain multiplication properly, then we'll be able to implement the string addition part in the matrix chain multiplication itself. So we will then what we will do is, we'll say that we'll have the minimum initialized as int maximum. then we will try to partition it at every step. So I am starting from I and ending at J. So I suppose I've been given a matrix A, B, C, D. So I'll try to partition it at every step. So I'll start at K is equal to I and K is less than equal to J minus I, K plus plus. Then the number of steps at that particular point would be nothing but the left part that gives me from I till K, from I to K, passing the array and the DP as the same. Then from K plus 1 to J. So this is the left part that I get. This is the right part. So left part plus right part plus the current multiplication. That is nothing but array of I minus 1 into array of J into K. As we were discussing for these cases. Like for this case, there will be a left part that we have already calculated. Then there would be a right part plus the dimension. So suppose A cross B is the dimension and C cross B cross C is the dimension. So plus left plus right plus A into B into C. Okay, that will be our overall cost. So we will see that. Then if it is minimum, then we'll store it, and then after we have done the computations for this particular suppose we have done the computations for this particular state, then what we'll do is we'll try to store the minimum, and for this DP of IJ we'll store the minimum. Okay, so that is how we'll be minimizing our number of operations at every step. Now talking about the brackets in matrix chain multiplication. So basically, suppose if the dimensions are given to you, suppose the dimensions are given as 1, then let's say it is given 10, 20 and 30 and let's say 40. So basically how many matrices would be there? There would be 3 matrices. So if ABC is there, so we need to determine that whether A then BC is doing giving us a minimum operations, or AB and then C is giving us the minimum of operations. So we can find this using the DP approach here only, but in this case we have to use the brackets, right? The concept is that we have to represent the matrices in terms of A, B and C, and we have to use the brackets as well. And for doing this particular approach, what we can try to do is we can try to have our DP which will not only be storing the value, right? In this case, the DP will not only be storing the operations or the minimum value for the particular I and J. It will not only store the minimum value, but also it will store the string. Okay, that is what will happen here. So let us discuss. I have taken this quote from the description. It was written really well. So basically what we'll be doing is we'll be declaring a vector of vector, but basically a 2D vector that will be consisting of a pair. The first part of the pair we have taken as a string, and the second part is integer. So the string part will be storing the brackets, will be storing the sequence in which we'll be storing the brackets according to the minimum operations, and integer will tell us the minimum number of operations. So initially we'll mark the string values as null, and we will mark the integer values as -1, indicating that the current DP state IJ must, if it is equal to -1, so that means that that particular state is not calculated. Then we'll call our function recursively, okay, passing this particular thing, passing this particular DP there, and we'll start from 1 to n-1. What we used to do in matrix chain multiplication, the concept is exactly the same. And then after this computation has been done, so we have to return what? We have to return the string. We have to return the brackets in the matrix chain multiplication, and that will be stored in the first part of this pair. So basically when this recursive function returns us, so if we have to have a pair, so in the this will return us a pair. So in the first part of the pair, the string will be stored, the brackets in the matrix chain multiplication will be stored in the optimal way. So that is what we have to return. We don't have to return the value in this case. So what the code is exactly the same. This function will return us a pair of string comma int, and will first of all pass the p array that has been given to us. We'll pass the I and the j, and we'll pass the dp array. Okay, and what we will do is if I is equal to j. So if I is equal to j, what does that mean? So if I is equal to j, so that means we have reached the base case. So if we reach the base case, in that case we know that we used to return 0. If you remember, we used to return basically 0. 0 meant that the cost was 0, and that was it. But here we have to use if we have to implement, so what we will do is we will have to generate all the characters A, B, C, D as well. So we can use this base case for generating. So based on the value of I, if the I value suppose is 1, then inside the string A will be stored. If the value of I is 2, then 2 will be stored. If the value of I is 3, then 3 like C will be stored. Okay, so that is how I will be storing the string along with it, along with the value 0. Okay, then we will check that if the particular state I comma j is not calculated, if the v of ij dot second is not equal to -1. So if it is already calculated, in that case I'll not calculate it again, because that will take a lot of time, and we will memorize it and simply return the value that we have already calculated. Otherwise we will mark our minimum as int maximum, and then we'll make a null string because we will be building up our string. So we'll try to partition at every index starting from I till k is less equal to j minus this thing, till like as we used to do in this part, like j minus I. So till like j minus 1 here, till j minus 1 we used to do it, right? So here also we will do it till this part only. Till this part only we will do, and we will first of all get the left part. This will be our left part calculated, okay? And we will also get our right part calculated here. And once we have our left and right part calculated, so we will calculate the current value. So current value is nothing but the left part, because left dot second will give me the value. So left dot second plus the right dot second, the right pair dot second, plus the computation, plus the plus this part. As I mentioned, if we have AB and CD, so if we get suppose the left part, okay, if we have the left part and the right part, so we'll add those values, okay, they are stored in the second, so dot second we can write dot second. And if the dimensions are of this kind, like in this kind, so in this case if it is 1 cross 2 and suppose 2 cross 3, so plus we will add 1 into 2 into 3, that is nothing but array of p of I minus 1 into p of j into p of k, and then we'll mark our string as null. So we will say that we need to do what? We need to store this in terms of bracket, right? We will store this particular string in terms of bracket. We will update our string only when, if the current value that we are having x, if it is lesser than the minimum value that we have seen up till now. So in that case we'll update a minimum value to x, and we'll update this string. So that will be nothing but, suppose if it was passed as AB, so we will store AB here, or we can store, let's say, BC here. Whatever is the current I value, based on that we will store it. And then after this computation has been done, so in v of ij, since v of ij is storing the pairs, so first of all we will store the string, corresponding string, and then we will store the minimum value along with it, and after storing we will simply return. So let us try and compile this code. So the code is very similar to the matrix chain multiplication, only in this part it is just that we have to use the string to return the brackets. So we can use the help of we can make this possible with the help of using pairs instead of just using the integer part. So that is how we are doing this particular approach. And in case if you did understood the explanation, so make sure to hit the like button and comment down understood as well. Thank you.